Hey everybody, welcome to Chem. We've got a problem here that's asking us about the limiting reactant. So let's see what it says. What is the maximum amount in grams of MgNO32 that will be formed if 21.3 grams of AlNO33 reacts with 2.43 grams of Mg? So a limiting reactant problem is trying to determine which reactant runs out first, basically. In order to do that, you have to complete a series of T-charts from the first reactant all the way through to the product, and then the second reactant all the way through to the product. Okay. I like to do little mini T-charts, so there'll be a total of 6 T-charts. Either way, you have to get the molar mass of the substances that you are being asked about. So looks like you're being asked about here this substance, and this substance. So above here, I'm going to calculate the molar mass for all 3 of these things. And I'll do the first one right up here. So Mg NO3 2. So step 1, write out what you see. You should see magnesium, you should see nitrogen, and you should see oxygen. Next step is to write out how many you see. So you should see that you only have 1 magnesium. This 2 outside of the parentheses gets distributed in. So you have 2 nitrogens here. And then this also gets distributed to that 3. And 2 times 3 is 6. Your next step is to get your mass from your periodic table. Magnesium is 24.31. Nitrogen is 14.01. And oxygen is 16. Okay, multiply across. So 24.31. This one is 28.02. This one is 96. Oops. And then add it up. And you should get that the molar mass of this substance is 148.33 grams MgNO32. And that is equal to 1 mole of MgNO32. Some students or teachers might have you write it as, grams per mole. I just like to write out the whole thing so that you can see that it's a conversion factor and you could flip it if you need to. And I'll explain what that means in a second. The next substance you're working with is AlNO33, and it's the same process. So write out what you see, aluminum, nitrogen, and oxygen. Then write out how many are there. Oops. So there's 1 aluminum. Take that 3 and distribute it in. There's 3 nitrogen. And then 3 times 3 is 9 oxygens. Get your mass from your periodic table. Aluminum is 26.98. Nitrogen, again, 14.01. Oxygen, again, is 16. Multiply across. So 26.98. This one is 42.03. And then 9 times 16 is 144 grams. Add it up and you will get 213.01 grams AlNO33, and that is equal to 1 mole AlNO33. The last substance is just magnesium. These ones are the easiest ones because all you have to do is find the mass from your periodic table. So magnesium is 24.31 grams, and that's equal to 1 mole of magnesium. Okay, so we front loaded a bunch of information, and hopefully that'll make our life a little easier when we're doing this calculation. So the first reactant that we're asked about is AlNO33. And I like to label my T-charts just so I don't get, goofed up. First T-chart I'm going to be working with here, I'll just write it up here, AlNO33. Okay. Well, they told me that I started with 21.3 grams of this substance. So that's my given value. And as always in a T-chart, your given goes over 1 or nothing, but don't put anything else in that box. So 21.3 grams AlNO3, 3. So that's my given value, and it goes over 1 or nothing. Okay, I need to cancel out my units. So the grams, these grams, I have to get rid of them. That means that I have to put them down here. They will only cancel if they're in the denominator. Well, good thing I did that calculation up here. So it looks like there are 213.01 grams equal to 1 mole. Well, I need grams on the bottom, so I have to put 1 mole AlNO3 3 in my numerator, and I have to put 213.01 grams AlNO3 3 in my denominator. Okay, your units match, you're good to go. Now in your T-chart, same process as always. You multiply across the top. So 2121.3 times 1. And then 1 times 213.01 is your denominator. You divide those two numbers and you will get 0.0999. There are more numbers after that, but I really don't like to round very much because the more you round, the less accurate your answer is. And then these units, top and bottom, cancel. Okay, meaning my leftover unit there is moles of AlNO3, 3. Okay, now I need to convert from moles of AlNO3, 2 moles of my product, which is MgNO3, So I got to take this number right here, and it is going to be my new given in my next T-chart. So 0.0999 moles of AlNO3, 3. And that's my new given. So don't forget, given goes over 1. I need to get rid of this. So that means that these units have to go down again. They don't go down, they won't cancel. Well, where do you get this information? Well, this is where I need to rely on my balanced chemical reaction. Okay, so I'm being asked about, at least in this T-chart, this substance, and I need to convert to this substance. So the mole to mole ratio comes from there, and it's that big number in front called a coefficient. So it says that there are 2 moles. So I know it's not written there, but in your head you should say that 2 moles AlNO3, and it's going to yield 3 moles MgNO3. Well, you can use that as a conversion factor, set it up in a ratio. What do I mean by that? Well, you could write it like this: 2 moles AlNO3 over 3 moles MgNO3, 2. And you could flip it if you need to. Okay. And if we look at our T-chart, it looks like we're going to have to because we need moles of AlNO3 in our denominator. So 2 moles AlNO3 goes down. 3 moles MgNO3, 2 goes up. Same process, multiply across the top. I'm going to get 0.2997. Multiply across the bottom, I'm going to get 2. Divide those two numbers, I'm going to get 0.14985 moles of what's left over. Well, what's left over? Not these guys. MgNO3, 2 is what's left over. Okay, I'm not done yet though. I'm closer, but I'm not done. I need to get to grams of this substance. So again, I'm going to take this number here and make it a new given in my next T-chart. And this is going to be my final T-chart. Okay, so 0.14985 moles Mg NO3 2. And I need to convert this to grams. Well, good thing I did that up at the top there, but let's make sure of what we need and where we want it. We want to get rid of these units here, which means they need to go right down here. Diagonal, if you will. Well, if I scroll back up to the top there, where I did that work, oops, too far. 148.33 grams is equal to 1 mole. So I'm going to pop that in right down there. 1 mole goes on the bottom because that's the unit I want to get rid of. And then 148.33 grams goes up. Same process, multiply across the top, and you will get 22.23. There's 1 is the denominator, so that's your final answer. So 22.23 grams Mg NO3 3. You know it's that because these units canceled. You're not done. I know it seems like a long process, but you're not done. Why? Well, you only figured out how much product you could make from the one reactant. You got another reactant that you were asked about, the magnesium. Okay? So your next portion, I told you at the beginning there were 6 T-charts, so this is 3. We're halfway there. So you want to start your next set of T-charts. This one is regarding magnesium. And they told us that our given value of magnesium is 2.43 grams of magnesium. Okie dokie. So 2.43 grams of magnesium is your given, goes over 1 or nothing. I want to get rid of grams of magnesium. If I want to get rid of them, they go down here. Okay, so I'm going to scroll up and see what I wrote up there. It looks like 24.31 grams of magnesium right over here is equal to 1 mole. So I need the grams on the bottom. So 24.31 grams of magnesium goes down. 1 mole of magnesium goes up. Multiply across the top. So that's 2.43 over 24.31. Divide. And you're going to get 0.0999. What units? Well, cancel them. These are gone. You're going to be in moles of magnesium. That is your new given for your next set of T-charts. So you're going to convert from moles of magnesium to moles of your product. So 0.0999 moles of Mg. Well, now this is a T-chart where I need to look at my balanced chemical reaction. So this time, I'm not using aluminum anymore. I'm using this one. So we need to go from here to here. So you should read that in your head. 3 moles Mg yields 3 moles MgNO3 2. So I still have to write it. So even though it's 3 to 3, I still have to write it. So the 3 moles of magnesium goes on the bottom. And then 3 moles Mg NO3 3 goes up. And I knew that I wanted that down because I want to get rid of it. Okay, so multiply across the top and then divide by 3. It's going to get you the same answer. So it'll be 0.0999. And then what are your units? Well, cancel the ones you don't want. And it's going to be moles of Mg NO3 3. We're almost done. This number here is the beginning of our final T-chart. 0.0999 moles of Mg NO3 3, and I need to convert this into grams. So for the last time, I just need to get rid of my units, which means that moles, get a different highlighter color here, that these moles need to go down here. So if I look up at this T-chart, or I could go all the way back up to my work, okay, it's 148.33 grams per 1 mole. So 1 mole MgNO3 is equal to 148.33 grams of MgNO3. Multiply across the top, and you're going to get 14.82. And what are your units? We'll cancel the ones you don't want. You're going to have grams of MgNO3. Okay, now what do we do? Well, now we need to compare our answers. So this is saying that if you use up 100% of your first reactant, this is the maximum amount of product that you can make. The second T-chart is telling you if you use up the maximum amount, you use up all of your reactant, this is the maximum amount of product you could make. You cannot make more than your minimum value. Okay, so you cannot possibly make 22.23 grams if you're limited by your other reactant. Okay, so the limiting reactant is what you started with. So the magnesium in this instance is the limiting reactant. Okay, how do you know? Because it's what's limiting you. It's what's running out first. You can't possibly make more than what you are limited by.